Okay, so we got stuck on our triangle. Let me back up for Lily so she knows where we are here. Alright, so we set up a picture for our example 1. We labeled everything that we were given. We realized we had to find angle C, side B, side C, but we are stuck because it's not a right triangle. We can't use trig ratios and we can't use Pythagorean theorem. Okay, in comes the hero, the law of sines. Okay, how do we find area of a triangle? What's our formula? Base times height, what? Okay, or sometimes we say, okay, either formula, it's the same thing. So 1/2 base times height is the one that I have on here. That is the same as base times height divided by 2. So we'll go ahead and write that, because sometimes people prefer to use that one. Okay, same thing. Alright, so look at all 3 of these triangles. It's kind of an illusion. Do they look like the same triangle to you? Because they are. But don't they sort of look distorted because I have different heights drawn in? So when we find the area, we need to know the base and the height. Well, the base doesn't have to be the side it's quote-unquote sitting on. It can be any side. And the height is the perpendicular distance from the opposite vertex. So looking at this first picture, side B is the base, and then this dotted line X would be the height. Well, X is not a side of the triangle, right? When we come over here, this is the base, so this would be the height. And then the third picture, we're using this as the base, and that would be the height right there. So all these heights are inside the triangle, but they are not a part of the triangle, and a part being the sides and the angles. Okay, so let's take a look at angle A in this first picture. And ignore the little small triangle that's on the right. Looking at angle A, I could say the sine of A is opposite over hypotenuse, x over c. So sine of A is opposite over hypotenuse. And if I get rid of that fraction and I multiply both sides by c, then I get x equals c sine A. Does that make sense? Okay, so c sine A is what x equals. It's written down here, but I wanted you to see where that came from. Because if I just said x is c sine A, hopefully you would have been a little confused and said, why? Wait, back up. So that's where it came from. Okay, let's go ahead and do the same thing over here. And we're going to refer to angle C. So ignore the little triangle on top. This is opposite. This is the hypotenuse. And then part of A would be the adjacent. So if I look at sine of angle C, it would be opposite over hypotenuse y over b. So sine of angle C is opposite over hypotenuse. Okay, but if I want to solve that for y, I would multiply both sides by b. And then I would get y equals b times sine C. Y is b sine C. Okay, that's where this came from underneath. And then the last one over here, we're going to look at angle B. So that little bitty triangle up there at the top, opposite is Z, side Z, and the hypotenuse is A. So if I said sine of angle B is opposite over hypotenuse. And because my 2's look like Z's, I put a little line through my Z's. If I get rid of those fractions, multiply both sides by A, then I get Z equals A sine B. And that is where that stuff underneath that triangle came from. Okay, so all I've done so far is solved for the height. If you'll notice, each one of these pictures, X, Y, and Z, represent the height of the triangle. But I represented the height using parts of the triangle. So I rewrote that height using a side and the sine of an angle. I rewrote that height using a side and the sine of the angle, etc. Okay, so let's go underneath all three of these and set up what the area would equal. So I have area equals 1/2 base, which is B, times height, which is X. Okay, well, that means that area is 1/2 B times, I'm going to use, in the place of X, this stuff that I found up here using parts of the triangle. So for the height, I'm going to use C sine A. Questions? So I'm just using that in place of the height because this has parts of the triangle in it. Okay, I'm going to go through and do the same thing for the next picture. So area equals 1/2. In this setup, the base is A and the height is Y. But in the place of Y, I'm using this stuff up here that we derived. So area equals 1/2 A B sine C. And then I'm going to do the same thing for the third one. I have area equals 1/2. In this diagram, the base is C and the height is Z. But in the place of Z, I am going to use this. So I have area is 1/2 C A sine B. Okay, so every single triangle is the same here. So shouldn't the area be the same? Like if it's the same exact triangle, no matter what I use as the base and the height, I should get the same amount of area inside the triangle. So what I'm going to do next is just set these two equal to each other, because those two areas must be the same. Well, if area is this and area is this, I'm going to use the transitive property and say that these two things have to be equal. So 1/2 BC sine A is equal to 1/2 AB sine C. What do you see on both sides of that equation? 1/2 and? But the word sine doesn't by itself, like I can't separate that from the A and the C. So I don't have sine A on both sides, I don't have sine C. Y'all are missing one more thing. B. So I'm going to divide both sides by 1/2 B. Okay, so what's going to happen is those cancel and those cancel. All right, so what's left is C sine A equals A sine C. Okay, next step, I am going to divide both sides by sine A sine C. I can divide by whatever I want as long as I do it both sides. Over here, sine A's cancel. And on the right, sine C's cancel. And what's left is C over sine C equals A over sine A. So remember, the little letters are the sides and the capital letters are the angles. Okay, so sine of angle C, sine of angle A denominators, the sides C and A are in the numerators. Okay, almost done. if all of these triangles are the same and all of these areas are equal, then I'm going to do a similar thing with these two areas, and I'm going to set them equal to each other. So if A equals this and A equals this, then these two have to be equal using the transitive property. So 1/2 AB sine C equals 1/2, I'll leave it CA. Kind of want to rearrange that alphabetical, but we'll leave it. Okay, what is common to both sides? 1/2 and A. So I'm going to divide both sides by 1/2 A. And cancel, 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 cancel. All right, so what I have left is B sine C equals C sine B. What do you suppose I'm going to divide both sides by? Sine B sine C. Sine B sine C, sine B sine C. Sine C's cancel there, sine B's cancel there. So what's left is B over sine B equals C over sine C. Okay, well, we can use our transitive property again. If C over sine C equals A over sine A, and C over sine C equals B over sine B, what's my conclusion? Yeah, A over sine A also equals B over sine B. So at the bottom, there are all three of them equal to each other, and those combined are what we call our law of sines. Okay, so I will not ask you to derive these. I just think it's interesting to see where they come from. Some of the formulas we've used, we have just strictly used them. But when it is good to see or easy enough to see where they came from, I do like to see that. Okay, so those are our law of sines. Yes, they are on your sheet, but take a look. They are right here in this box right here. How are they different? Okay, Greek letters. And what else? It's switched, isn't it? The sign of the angle is up top. That's fine. If I have two fractions that are equal, if I flip them both, then they're still equal. So you can set it up this way. Generally, I would say this is the more common way to set it up, but it can be either way. So it's a little bit opposite on here. I'm going to highlight it, and if you don't like the way it's written there, then you can rewrite it down at the bottom if you would like and make it this way. But this is the way I will always set it up, with the sides on top and the angles on the bottom. But it can be done backwards and work out the same way. Alright, so now the whole point of this was this triangle right? No, that's an acute triangle. So the good news about this law of sines is it can be used on any triangle. It can be acute, right, or obtuse. Doesn't matter, because clearly these were not right. All right, so let's go back to our triangle that we had here. And now that we know our law of sines, we have a new tool to use. So I'm going to write out the law of sines over here. And you will just memorize these. I don't think you'll even have to look on that sheet. That's just super simple to memorize, isn't it? The A's go together, the B's go together, the C's go together. Okay, so when I use the law of sines, I pick which two I want to pair up. And which two you pair up depends on what information you're given. So let's say that I chose the A's and the B's together. Then I need to know 3 of those 4 things. Only one thing needs to be missing. So one angle could be missing or one side could be missing. If 2 things are missing, then I can't get anywhere with it. All right, so let's look at the A's and the B's. Do I know angle A and side A? Yes. I know angle B, but I don't know side B. So that means I can use the A's and the B's together. Okay, what I could not use together are the B's and the C's, because I don't know side B or side C. So if I set up these two, both of these would be unknown and I wouldn't be able to solve for anything. Does that make sense? Yes? Okay, so let's set up the A's and the B's. So I'm going to set up these two together. So side A was 8. Angle A is 36. So over sine 36 degrees equals side B, that's unknown, but sine of angle B is sine of 48. Everybody okay? How we got this? Okay, so when we have two fractions that are equal, what's that called? Starts with P. Come on. Two fractions that are equal is called a proportion. And what is one way to solve a proportion? Is Charles responsible for that answer? Thank you. How do we often solve proportions? Cross multiply. Okay, cross multiply. So when I cross multiply, B times sine of 36 is equal to 8 sine of 48. Now, the true reason why we cross multiply, what do we do when we want to get rid of fractions? What do I usually do? Multiply by the denominator, right? Well, I have two denominators here. If I multiply both sides by both denominators, what ends up multiplying together is the 8 and the sine 48 and the B and the sine 36. So this is just a shortcut to multiplying both sides by denominators. That's why we cross multiply proportions. Okay, what is it I'm trying to solve for here? B. Why is B not by itself? It's multiplied by what? Sine 36. If it's being multiplied by sine 36, we get rid of it by dividing by sine 36. All right, so on the left-hand side of my equation, sine 36 cancels, and I have B all by itself, which is what I was trying to do. And then on the right, we're going to go to our calculator and type all that in after checking the mode. Make sure the mode's in what? Degrees, because our angle is in degrees. Angles are in degrees. Okay, so we're going to type that in, fraction 8 sine 48 over sine 36. You know what, I didn't check my mode. Okay. And there we go. Generally on sides, I'll say let's round just one decimal, and on angles, we'll go to the nearest whole number. So I'm going to call that 10.1. So 10.1. And now I do have that known over there. Okay. Question on that? Okay, so now that I know two sides, can I use Pythagorean theorem to find the third? No, it's still not a right triangle. So that's still not an option. So what do? We go back to law of sines and pick a different two. So I always stick with the pair that was given because we rounded that number, right? 10.1 we rounded. So I'm going to stick with the A's. So I'm going to use A over sine A. But I'm trying to find side C now. So I'm going to use the C and the sine of 96. Oh, hang on. Getting ahead of myself. Sine C. Now next step I'll fill in. Okay, so then that gives me 8 over sine 36 equals C over sine 96. Does everybody see where I got that? All right, we're going to cross multiply. And that will give me C sine 36 equals 8 sine 96. Okay, I'm solving for C. It's being multiplied by sine 36. So to get rid of that, I have to divide by sine 36. Okay, these cancel. I'm going to go to my calculator, type that in. 8 sine 96 over sine 36. And we'll call that 13.5. 13.5. Okay, now before we circle it and move on, I want you to do this. Do you remember from geometry that the smallest angle is always opposite the smallest side? Largest angle is opposite the largest side. So just double check your triangle and make sure that that is true. So find your smallest angle, 8 is the shortest side. The biggest angle was 96, 13.5 is the longest side. So it's sort of a check to make sure that everything worked out. And then that is what we were looking for. Question? All right, so we'll do one more together. This one should go quicker. All right, first step is what? Draw a triangle. Make it some generic triangle. Put your A, B, and C wherever you want. And then label the information that I'm giving you. 40 degrees goes here. 30 degrees here. Side B is 10. I am looking for angle C, side A, and side C. All right, good with the picture and labeling. Okay, so think back to these three fractions. Which one do I have to include to get started? The B's, because I know both of those. Okay, so I'm going to have to use B over sine 30. Okay, now can I do either A or C next? I could do either if I went ahead and found angle C, which some of y'all probably already did, didn't you? So if I add those, I get 70, so angle C is 110. Clearly that doesn't look like 110, but that's okay. Okay, so do you want to find A or C first? A. All right. Side A over sine of angle A. Cross multiply. A sine 30 equals 10 sine 40. And what next? I want A by itself. Divided by sine 30. Those will cancel. I will go to my calculator and type that lovely fraction in. And we'll call that 12.9. All right, 12.9 is A. Can I use Pythagorean theorem now? No. If I end up with a 90-degree angle, then by all means, yes. But not the case here. All right, so again, I'm going to stick with that B over sine B because I didn't round that number. I rounded this 12.9, so generally I'll use the one that's given. It just makes it a tad bit more accurate to not use a rounded value. Okay, clearly we have to find C next, so C over sine 110. cross multiply C sine 30 equals 10 sine 110. You can cross multiply either direction first. I just usually put that variable on the left. Divide by sine 30. Go to your calculator. Aren't these easy? 10 sine 110 over sine 30. And we'll call that 18.8. And 18.8. Okay, so let's make sure. Let me fill this in. 12.9 and 18.8. Go back and make sure, is the longest side opposite the biggest angle? Is the shortest side opposite the smallest angle? Yes, looks good. We are done. Question. It is pretty simple, isn't it? All right, so that's what we're going to do for homework. Let me hand those out.